All right, guys, we're going to be finding the trig ratios for the triangle that is being shown in this circle. And you can actually see that triangle right here. It is getting traced out that we have a triangle right there. Now, a couple of things we need to do is revisit those trig ratios. Remember that trig ratios are sine, cosine, and tangent, okay? And when we do this problem, we're gonna be writing sine, remember, is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So what we wanna do is, let's go ahead and write it from this base angle right here. We'll call this A. We will call this B, and we will call this C. And we do have a right triangle. And so remember, we give those names A, B, C based off of in capitals, and then we just write the other ones in lowercase, A, and then we'll call this one B, and then we will call this one C. All right, so let's go ahead and write it from A to start this. So we want to find the sine of A, the cosine of A, and the tangent of A. Now, the first thing I always do when I find my trig ratios is identify what does this mean to be the opposite, the hypotenuse, and the adjacent. Easy, okay? We know that the hypotenuse is right across from that right angle right here. So we know this is going to be the hypotenuse. Boom! We know that the opposite, if I start from the angle that I'm shading, I go clear across to the other side of the triangle. That is now the opposite. And then when I turn to the non-hypotenuse side, that is what we would call our adjacent. So that is our adjacent side right there. Okay, so let's go ahead and label some things that we do know about this triangle that we know a little bit more of. So the first thing we're given is we're given this 0.68. Remember, 6 is in the X position, 8 is in the Y position. So that tells us that we've gone over 6, we've gone up 8 in order to get to this point right up here that is at the end of the hypotenuse. Okay, well, let's find the length of the hypotenuse. Well, we use the Pythagorean theorem. Remember, a squared plus b squared equals to c squared. So we just say, okay, well, what is that? 6 squared plus 8 squared equals to c squared. And I know 6 squared is 36, 8 squared is 64, equals to c squared, and 36 plus 64. You can throw this in Desmos and check it if you don't trust me, but 36 plus 64 is 100, and we're going to put it into c squared, and then we take the square root. C comes out, and the square root of 100 is 10. So that means that this length is 10. Now we've got everything we need to find sine, cosine, tangent, okay? So let's go, and we're gonna reference what we have here. So sine is opposite over hypotenuse. So I started with this green angle there, and I say, okay, well, sine is opposite, so I go opposite 8 over the hypotenuse, which is 10. So I just write 8 over 10, and that simplifies to 4/5. I do cosine. Cosine is adjacent over hypotenuse, okay? So I do, where is the adjacent? Adjacent was right here. So that is 6 over 10, 6 over the hypotenuse, which is just 6/10. We divide by 2, 6 divided by 2, 3. 10 divided by 2, 5. So we get 3/5. And then we go to tangent. Last one is tangent, opposite over adjacent, okay? And what I'm gonna do is say opposite. Well, the opposite is 8. Okay, and the adjacent is 6. I'm going to write 8 over 6, which is 4/3. Now, as we're doing this, we can also switch it up a little bit. And some people will say, okay, well, we already know our opposite or adjacent, so let's just go ahead and switch it up just a little bit. That was from angle A. What if I switched it up to be from angle B? Okay, well, if I wanted it to be from angle B, I would shade angle B, and I'd say, well, what is the sine of B, the cosine of B, and tangent of B? Okay, now check it out. We do the exact same thing. The hypotenuse stays in its same location, but notice this. The opposite is change. The opposite, remember, is clear across from the angle. So the opposite is right across, it is over here. This is now our opposite. It switches, and this is now our adjacent because we're using a different angle. That's it. So now we go back to sine and we say opposite over hypotenuse. Well, from B, the sine of B, that is going to be the opposite. That's clear across. That is 6 over 10. That is now 6 over 10, or 3/5. Okay. And then we go cosine. Well, cosine is adjacent. So that is right here, adjacent over the hypotenuse, which is now 8/10, which is now 4/5. And then we go tangent. Remember, tangent is right here. It is opposite over adjacent. So I go opposite in red over the adjacent in red. So now it is 6 over 8, which is now 3/4. So when you find the sine and cosine and tangent, you have to have that first reference angle. Once you've got that, you just follow opposite over hypotenuse and all the language that goes with it. I hope this helps, and good luck.